Hello everyone, today we are going to talk about connective tissue. Although it doesn't form any distinct organ, it is present almost everywhere in our organism in form of layers and envelopes. It brings blood vessels to the organ, and together with the blood vessels it provides nutrients, nutritional support. Also it brings nerve endings, providing the regulation of different organs' activity. After that it contains lymphatic vessels and capillaries, taking all the wastes out of organs. And of course connective tissue, this is the site of inflammatory reactions. So understanding its structure and function is critical in investigating almost every organ in our organism. So let's start to investigate it. And we start from the classification. There are different types of classification. Almost every author has its own point of view. That's why we ask you to prepare exactly this one for practical lesson. And let's start to investigate it. First of all, we consider inside connective tissues a special group which is called connective tissue proper, so connective tissue as it is. And this type of connective tissue is represented by two, loose or areolar and dense. From their name we guess its consistency. Dense, it contains more fibers than cells, that's why it's a little bit dense, and loose, it contains more predominantly cells and ground substance, that's why it is more soft than dense connective tissue. Then dense connective tissue further is divided into two, regular, where all fibers are parallel one with another, and the classic example is a tendon. Tendon, it fixes a muscle to the bone, and in this way it contains it endures the high mechanical stress, and it has all collagen fibers oriented parallel with the same line. While irregular, dense connective tissue, it has all collagen fibers oriented in different directions. That's why it is called irregular, because there is no uniform pattern of their organization. And the classic example is the dermis of our skin, where collagen is oriented in different directions. So this is as for the connective tissue proper as it is. But also we have some specialized types of connective tissues, which are blood and lymph, and we have already considered it last time. And this type of tissue is unusual because it has liquid extracellular matrix. Then skeletal connective tissues is a special type of connective tissues with a dense extracellular matrix with mechanical function, and this is what we are going to consider next lecture. And after that we also have adipose tissue with a prevalence of adiposites, reticular tissue with a prevalence of reticular fibers, which is also called lymphoid or hematopoietic in modern textbooks, and those two we are going to consider at the end of this lecture. So also we have to mention that in the embryonic period there are two types of tissues which are not found in adults, but only before the birth. These are mesenchymal tissue. It is present in the embryo starting from the most early stages of development, and mesenchyma it derives from all three germ layers, and this is the connective tissue of the embryo. So mesenchyma derives not only from the mesoderm but from all three germ layers, and it is considered and it is classified according to its structure but not the derivation. And another type of embryonic connective tissue is mucous tissue. Mucus, it is present in the umbilical cord, and also we are going to consider it at the end of this lecture. Okay, so let's summarize this table. The connective tissue proper, that's what we are going to consider today. And then skeletal connective tissue, this is for the future topic. Blood and lymph we have already considered. And at the end of this lecture we are going also to consider some special types of connective tissue with specialized properties. Okay, also along the lecture we are going to consider our specimens, as during module you have to recognize them and to distinguish some elements inside. And our first specimen is a tendon. Tendon is an example of the dense, regular connective tissue with all collagen fibers oriented parallel. And you can see they are pink and oxyphilic, and they all are oriented along this line. And between collagen fibers we can see small cells, they are called tendinocytes. Those cells, they produce new collagen fibers, replace an old one. Notice that tendon is so thick and dense that it needs to be subdivided with a loose connective tissue into bundles. So here we can see loose connective tissue, which is represented by the so-called endotendinium, the connective tissue providing blood vessels and nerve endings inside the tendon, inside the dense connective tissue. Okay, and now let's first investigate three major elements of the connective tissue. These are fibers, ground substance, and cells. And we start exactly from the most difficult one, from fibers. Fibers are further divided into three groups: collagen, elastic, and reticulum. And we start from collagen fibers. Collagen fibers, that's what you have to know in general about their properties. First of all, they are relatively thick comparing with other fibers. They are unbranched and they have oxyphilic properties because they are positively charged. That's why they are stained predominantly with the eosine, as we have just saw in the specimen of the tendon. It was pink in color, oxyphilic. Then, collagen fibers, they consist of fibrillar protein, collagen. Fibrillar means thread-like, linear molecule they have. And that's exactly what you have to pay attention at. These are the two marker amino acids, hydroxyproline and hydroxylysine. Hydroxylated form of those two amino acids are characteristic exactly for collagen. That's why when we found them in the urine, for example, this is the sign of collagen, massive collagen degradation, and it is used as a diagnostic criterion. So you have to remember those two amino acids. It is important. Then, what about the functions of collagen? There are two most important. First of all, this is the tensile strength. What it means? It means if we take a collagen thread 1 millimeter in diameter, it could endure the weight of nearly 40 kilograms. So it really has very high tensile strength. So that's why tendons are made up of collagen. So it prevents tearing of our tissue. Then the second very important function is water retention. Because of the presence of hydroxylated amino acids and positively charged amino acids, collagen is charged, so it orients lots of water molecules around it. It provides the moisturizing of different tissue and the hydration of different tissues. For example, our skin, when collagen is present in enough amount, skin is well hydrated. When collagen decreases with aging, when it breaks down, when it degrades and is not produced, then wrinkles appear. That's because water couldn't be retained in the tissue no more. So to retain water, collagen is needed. Besides, the name collagen means generating glue generating substance, because when we take collagen, add some water, then collagen form viscous-like substance, glue-like substance. Okay, so remember those two important functions. Then collagen fiber synthesis, that's what is very important and critical event in our connective tissue. First, collagen is produced in the ribosomes, as all proteins do. Ribosomes on the rough endoplasmic reticulum, they produce pre-pro-collagen molecule inside the cisterns of the endoplasmic reticulum. Here, this pre-pro-collagen molecule. Then, what happens with it inside endoplasmic reticulum? It undergoes hydroxylation. As you remember, lysine and proline residues should be hydroxylated. And This is exactly what happens in the rough endoplasmic reticulum. In this process, vitamin C is very critical. So please remember, because now you can understand why deficiency of vitamin C is called scurvy, besides, and why it is so severe pathology. Because in case of vitamin C deficiency, all basement membranes impaired, and blood capillaries become fragile, wound healing is impaired and violated. So the very severe symptoms it has because of problems with collagen synthesis. So please do associate vitamin C with collagen synthesis. After that, also besides here, glycosylation also takes place inside the rough endoplasmic. Then the three pre-procollagen molecules, after their modifications, they are intertwisted one with another with the formation of triple helix structure, which is now called procollagen. So pre-procollagen is then transformed into procollagen. And procollagen is further through the Golgi complex, is excreted, exocytosed out of the cell. So those triple helices are exported out of the cell, and the next step is extracellular. So after that, collagen continue to be produced. Yes, the assembly of collagen fibrils takes place outside the cell. So being exocytosed, procollagen molecule is undergoing the end pieces cleavage. So end tails are cut with the help of a special peptidases outside the cell. So tropocollagen is formed in this way. As you can see, the difference between the tropocollagen and procollagen is in the absence of those end pieces. And as those end pieces are cut off, now tropocollagen molecule, they undergo self-assembly process, and without any external help, they form long fibrils by stacking with their lateral surfaces one with another. As you can see, they contact one with another with their side along with their long axis, and they form fibrils in this way. Further, thin fibrils, like small threads, are intertwisted with the formation of fibers, like thick ropes are formed out of thin threads. In the same way, fibers are formed out of fibrils. And some types of collagen fibers not responsible, they are capable of forming bundles of fibers. Bundles of fibers are characteristic for collagen type 1, and exactly this type forms our bones, tendons, and intervertebral discs. So we can see those fibers even with an unarmed eye because they are very thick. So usually fibers are the final stage for collagen synthesis, but sometimes fibers further assembled into bundles of fibers. Okay, and what we have to add is that by stacking one with another, tropocollagen molecules do not contact end to end, but instead there are some gaps are formed between them. That's why, because of those gaps, some regions of collagen fibers, they appear more lightly stained comparing with the other regions, more dark in staining, because here all tropocollagen molecules are overlapping one with another, and in some neighboring regions some gaps appear, so this region is going to be a little more lightly stained. That's why for collagen fibers cross striations are characteristic under the electron microscope. So please remember, under light microscopy cross striations are not visible. Like for muscle tissue, cross striations could be seen even under the light microscope, but for collagen, cross striations could be found only under the scanning or transmission electron microscopy. Okay, I think this is all about collagen fibers. They're very important, and remember, they prevent tearing, and at the same time they provide hydration for our tissues. And now we have to say that collagen degradation is also a normal process which is balanced with the collagen synthesis. To remove old collagen fibers, special enzymes are needed, and these are matrix metalloproteinases. Here they are listed, and you remember that some of them we have already mentioned last time when we had the topic blood, because they are present in neutrophils. also in fibroblasts, macrophages, and cancer cells. And maybe you remember that neutrophils needed those enzymes to migrate inside connective tissue to reach the site of the inflammation, because connective tissue is rather dense substance, and to migrate inside it, collagen fibers need to be cut by some cells, and breaking down collagen facilitates the migration of different cells. In case of neutrophils and fibroblasts, this is the normal process, but cancer cells use those enzymes to send metastasis. That's why blockers of those enzymes are used to prevent metastasis. So please remember, those enzymes are used in diagnostics and they are the target for different drugs in chemotherapy. Okay, let's move on. And after that, after we have considered structure of collagen fibers, the process of their synthesis and degradation, we go to reticular fibers, and they are not so widespread, but what's unusual with them is that they are made up of the same protein called collagen type 3. But in their three-dimensional structure, by their properties, they differ significantly from collagen. That's why they have their distinct name. That's why they are called reticular fibers. Okay, because what's the difference between collagen and reticular fibers? Reticular fibers, they are thin, branched, with argyrophilic properties. Compare with the collagen, which are thick, unbranched, and oxyphilic. Quite another role. So what does it mean argyrophilic? Because they are stained with the argentum salts. Silver salts are needed to visualize them under the microscope. Then they are present in the hematopoietic and lymphoid organs, in the red bone marrow, spleen, and lymph nodes, some other organs as well. So they provide three-dimensional scaffold for organization of those blood cells inside different organs. They do not provide tensile strength and water retention, so they have quite another properties and functions. Okay, let's move on and talk about elastic fibers. Elastic fibers, their natural color is a little bit yellowish. That's why we can distinguish elastic cartilages or ligaments by the color when they are unstained. They made up of they are represented by thin, branched, argyrophilic fibers. So like reticular fibers, elastic, they are thin, branched, and stained with the argentum salts. Then they are represented by the globular protein elastin. As you remember, collagen was made up of fibrillar protein. Here, globular spherical protein molecules are used. And marker amino acids, please also remember them. These are desmosine and isodesmosine. They are specifically found in the elastic fibers, so you have to associate them strongly with them. About their function, we'll talk later. As for the function of elastic fibers, it is obvious from its name, elasticity. Elasticity means that structures, after the deformation, they return to the initial shape. For example, if you change the shape of the ear auricle, then it returns to the initial shape itself. As well, if you do this with your skin, it again returns to the initial smooth surface pattern because it contains elastic fibers. So elastic fibers, they do provide stretching for organs, and after stretching, the possibility to return to the initial shape. And let's consider the steps of elastic fibers formation. They have very complicated three-dimensional organization. First, globular molecules of elastin are produced by the cell. Then they assemble into protofibrils outside the cell, and then small microfibrils are formed. Here exactly they are shown. And microfibrils, they are used as the site of globular elastin deposition on their surface. And as a result, mature elastic fibers, they are represented by the globular amorphous elastin in the middle, in the core of the fiber, with microfibrillar network around it. So microfibrils, they form like a network on the surface of elastic fiber, while inside elastic fiber there is a jelly-like substance. And how it works, this diagram clearly demonstrates us how elastic fibers could be stretched and how they maintain their shape. Originally, microfibrils, they are curly or coiled small molecules which are interconnected one with another with the help of those desmosine and isodesmosine amino acids. That's the function of those marker amino acids. They provide cross-linking between the microfibrillar components. So when we stretch them, every coiled molecule becomes linear. We will stop stretching, then they return to their initial coiled shape. And to prevent overstretching of elastic fibers, as they are not so strong as collagen, usually they are accompanied by collagen fibers. So collagen, it prevents overstretching, while elastic fibers, they provide returning to the initial shape after stretching. So they are usually used together, and they are present almost everywhere in different ratio in almost all organs. And here what we can see under the scanning electron microscope, here is the elastic fiber with microfibrils on its surface and amorphous elastin inside, and collagen fibers with thin fibrils with the cross striations. So notice fibrils connected together and form thick fiber, which is much more thick than elastic fiber itself. Okay, and here is the next specimen. We have already considered dense regular connective tissue as the tendon, and here is the example of the loose areolar connective tissue proper. And in this specimen we can distinguish collagen fibers, here they are thick, wavy shaped, unbranched, and elastic fibers which are branched and much more thin comparing with the collagen. And that's almost everything we can distinguish clearly, because there are also some cells, but their shape couldn't be recognized exactly in this specimen. So let's move on. And after we have considered three types of fibers, collagen, reticular, and elastic, now we talk about ground substance. Ground substance is another part of the extracellular material. So outside the cell we can find fibers and ground substance. Ground substance is a viscous jelly-like substance which provides diffusion of different molecules, migration of different cells, and its composition is responsible for the metabolic rate in different tissues and organs. So there are two main components of ground substance. First, these are proteoglycans. Proteoglycans are called so because they are made up of protein and carbohydrate or sugar molecule. And sugars predominate in the structure of the molecule. They are more numerous. That's why proteoglycan, meaning that glycan is at the center of the molecule. This is the most important part, while protein plays a secondary role. And proteoglycans, they made up of only one core protein, again because protein is the secondary molecule in this case, and many glycosaminoglycans, which are sugars, many glycosaminoglycans. And here exactly proteoglycan is shown. Here we can see in the center, this is the core protein, and those needle-like structures, these are glycosaminoglycans. And as you can see, those glycosaminoglycans, they prevail in number. They are much more numerous than only one single core protein. That's why the molecule is called proteoglycan. Glycan because sugars predominate. Now, those glycosaminoglycans in this case, they are sulfated. And it is very important to say that those needles, they differ in their structure, and they are represented by three: keratan sulfate, heparan sulfate, and keratan sulfate, chondroitin sulfate, I'm sorry. So as they are sulfated, they are negatively charged, so they are stained with basophilic dyes usually, and they attract water. They also absorb lots of water molecules, and they help to retain water in tissues. So together with collagen, they are very responsible for normal moisturizing of our tissues and skin particularly. So in cosmetology, we try to boost the formation of those proteoglycans and their aggregates together with the collagen molecules. And one more important molecule should be mentioned here. This is the hyaluronic acid, which is non-sulfated form of glycosaminoglycans. And exactly here it is. We can see that hyaluronic acid is a lone centrally polymerized molecule which is non-sulfated, and it is used to add many proteoglycans with the help of linker proteins. And together, hyaluronic acid with proteoglycan molecules, they form so-called proteoglycan aggregates. So outside the cells, we can find many such molecules with hyaluronic acid in their center and many proteoglycans added to it. This molecule is strongly negatively charged because those molecules are sulfated, and they absorb and retain lots of water. That's why they are so helpful and so important for our tissue homeostasis. And exactly, hyaluronic acid is also broken down by different matrix metalloproteinases together with collagen fibers by cells migrating in the connective tissue. Okay, and we have to say that another group of ground substance molecules, these are glycoproteins or multi-adhesive proteins. They are called glycoproteins because they have protein in the center of the molecule and short branched sugar glycan added to the protein. So here protein prevails while sugar plays a secondary role. It is a small part of this molecule. Those molecules are called multi-adhesive because they help cells to adhere to the extracellular matrix. For example, one of those proteins you already know, this is the laminin, and it is present in the basal lamina, and it helps cells, epithelial cells, to attach to the basal lamina. Or, for example, fibronectin molecule is called so because it connects cells to fibers, fibronectin. On the one hand, it attaches to integrin receptors on the surface of cells. On the other side, it attaches to fibers and ground substance components in the extracellular matrix. So it helps to adhere cells to extracellular matrix elements. It helps in migration and just in their proper position. Okay, so let's move on, and this is very difficult maybe to remember because complicated names, because you have not yet had your biochemistry lesson in this topic, but I think only short information is briefly concentrated here, so please do study and remember this slide. Next, after we have discussed, let's skip that, after we have discussed our fibers and ground substance, we are moving to the cells. And before doing that, we have to say that in the ground substance, in this extracellular matrix, a special structure which is called interstitium was discovered several years ago, and it was called a Newfound organ, but of course, just only to boost its popularity among the scientific news, but in any way, it is very important discovery, I guess. What is it itself? Some scientists they noticed that in the connective tissue among fibers there is a special system of channels or fluid-filled spaces are present. They are lined with collagen fibers, and they are used by different cells for migration to the lymphoid system. And this system of fluid-filled spaces is very important in understanding how cancer cells do send metastasis, for example, how inflammation is spread in different organs. So its investigation is very promising and very prospective direction in modern histology. So if you are interested, please read more, because we know about lymphatic capillaries, but as for the interstitium or fluid-filled spaces, so we are not aware right now. Okay, now about cells. Cells really do a very important function in the connective tissue, and they are represented by resident cells, which could be found always in the connective tissue, and some of them appear by demand under some special circumstances. So let's investigate them one by one. Okay, fibroblasts. Fibroblasts are young, immature, and they are called so because they produce fibers. While fibrocytes, these are the same cells but mature with less prominent synthetic activity. They have less developed rough endoplasmic reticulum and Golgi complex and lower synthetic activity. So yeah, that's what's written here, fibroblasts and respectively fibrocytes. Then their functions to produce all the components of the extracellular matrix, and also we have to mention that among them there are some myofibroblasts. These are the cells with contractile properties on the one hand and fiber producing activity on the other hand. Their function is to assist in wound healing process. So they contract them. By contraction, they migrate to the site of wound, to the tissue defect, for example, and here in the tissue defect they try to approach opposite edges of the wound one with another using their contractile properties, and at the same time they produce fibers filling the defect with a scar-like tissue. So myofibroblasts, these are the modifications of fibroblasts, and these are the fibroblasts transformed into myofibroblasts. Okay, what else I wanted to add here is that fibroblasts, they derive from the mesenchymal, from the embryonic connective tissue, so they are residents of the connective tissue. Then macrophages, these are the second by their number cells. They derive from the monocytes of the bloodstream, and after that macrophages present in connective tissue of all organs. Once again, connective tissue is present almost in every organ, and macrophages present in the connective tissue. So all macrophages of our organisms, they're united and are considered as a single system, which is called mononuclear phagocyte system. It is called mononuclear, opposite to the segmented nuclei of neutrophils. So mononuclear means they derive from the monocytes. And functions, as we have already said, they are antigen-presenting cells, and at the same time they have they are phagocytes. Yeah, they phagocytose different bacteria cells. And in details, functions of macrophages we consider next lecture about immunity. But now we have to say that there are two types of macrophages. Depending on circumstances, sometimes they could stimulate inflammatory reaction or inhibit it. So we have classically activated macrophages and alternatively activated. And please remember, because it is very important really, the presence of macrophages doesn't mean inflammation by default. It depends on the type of their activity by circumstances. So if in case of bacteria present, macrophages are classically activated. At the end of inflammation, they start to stimulate reparation, the blood vessels growth, which is called angiogenesis, and so on. And sometimes macrophages, if they fight against a large invader, a large foreign particle, they unite, they fuse one with another with the formation of one giant multinucleated cell, which is called foreign body giant cells. That's what you have to know, and you'll discuss in pathological anatomy further. Okay, mast cells, they are almost the same as basophils of our bloodstream, so they have very similar set of enzymes, but at the same time they derive from another progenitor of the bone marrow. You remember that in our bone marrow there are two progenitors for basophils and for tissue macrophages, for basophils and for tissue mast cells. Mast cells, they circulate in the bloodstream in undifferentiated form. So they start to differentiate only in the connective tissue, while blood basophils, they get differentiated inside the bloodstream. That's the pivotal difference. While mast cells, they have the same set of enzymes, heparin, histamine, their function you already know, and notice leukotriene C. This substance stimulates the contraction of smooth muscle cells, causing the bronchospasm during the bronchial asthma, for example. So lots of pharmaceutical drugs are blocking it. So that's why you have to know not only histamine, because many antihistamine drugs are invented, but also the leukotriene, because it is important for your future pharmacology knowledge. Okay, and of course, eosinophil and neutrophil chemotactic factor. I do not stop on those substances because you are already aware about heparin, histamine, and those as well. Functions, the same as for basophils. They are present close to blood vessels because they increase their permeability, causing edema and attracting other cells. And plasma cells. Plasma cells also derive from the bloodstream, and they produce antibodies. They derive from B lymphocytes, they are activated by T helper cells, and they produce antibodies. As antibodies are proteins, plasma cells, they have very well developed rough endoplasmic reticulum, so their cytoplasm is extremely basophilic. And these are the two signs, two criteria, according to which you can distinguish plasma cells in the even light microscopy. First, the cytoplasm is extremely basophilic with light area occupied by Golgi complex close to the nucleus. So this light area on the background of the basophilic cytoplasm, this is the sign of plasma cell. Here Golgi complex is located. Another criterion is the chromatin arrangement. Chromatin is organized in a cartwheel or clock face appearance. As you can see here, heterochromatin clumps are condensed at the periphery of the nuclear membrane, and here we can see something like a clock face pattern, and this is really very characteristic appearance. That's what helps you to recognize plasma cells among others in the connective tissue. Please remember that. Then pigment cells. In Western textbooks, they are not mentioned as residents of connective tissue. They are really very rarely found in the connective tissue, but we have to mention. Actually, they derive from the neural crest, they produce melanin, and they protect from the ultraviolet radiation. But in details, you'll investigate pigment cells in the topic skin later at the end of the next semester. And now adipocytes, another important representatives. They store neutral fats and fat-solving vitamins like A, D, E, F, K. Those vitamins, together with the fats, are deposited in adipocytes. Also, they perform the function of thermoregulation and production of biologically active substances. And that's what we are going to consider at the end of the lecture when we talk about the adipose tissue itself. And at last, the last cells and the most important, these are the mesenchymal stromal cells or stem cells. These are the least differentiated cells, and they are used as the source of differentiation for adipocytes and fibroblasts. So they are regenerated out of the mesenchymal stem cell. And these cells are very promising source for personalized regenerative cell-based therapy. So we can obtain them from the connective tissue, and especially from adipose tissue. You know that some patients, they undergo liposuction procedures when they want to get rid of their fat. And what is especially interesting, this fat could be used to obtain mesenchymal stem cells. And after that, those stem cells could be reintroduced to the same patient to treat heart failure, different diseases of its kidneys, lungs, and many other organs, including retina, and many others. And lots of clinical trials are already investigating the potential of these cells. And after hematopoietic stem cells, these cells are on the second place by their popularity. So I believe they will be soon introduced to practice in many clinics. That's why you have to know about them. Okay, also we have to say that another name is adventitial stem cells, and in the around blood vessels in the connective tissue, some pericytes are present. So pericytes are also stem cells, but very similar to mesenchymal stem cells, but we are going to consider them in the topic blood vessels. And at the end, we have to discuss specialized type of connective tissue. As we have said, there is adipose, reticular, mucous, and several types we have already discussed, like blood and lymph, and bone and cartilage is to be discussed further in next lectures. So now we are going to consider adipose, reticular, and mucous. Adipose tissue. It is further divided into white and brown, and here is the brief description of them both and the comparison. The general difference between the two types of adipose tissue is that in white adipose tissue there is inside adipocytes, there is only one droplet, one lipid droplet, while in brown adipose tissue many small lipid droplets distributed in the cytoplasm. Then in the white adipose tissue, nucleus is shifted to the periphery, while in the brown it could be put in the center. That's why another names of this tissues, white is also called unilocular because one lipid droplet, and brown is called multilocular because many lipid droplets. Then the color of the white is yellowish because of the presence of vitamin A, which is keratin, and it is yellowish in color. And brown adipose tissue is brown because it contains many mitochondria. They contain cytochrome C, and cytochrome is almost the same as hemoglobin. These are the iron containing substance. So due to multiple mitochondria, it has its color. Also, this tissue is highly vascularized. It has multiple noradrenergic nerve endings, and this tissue could be found only in newborn children. In adults, it is almost absent. So in newborn children, these are the characteral places shown in yellow color where we can find this tissue. And what is the function of this tissue, and what's the difference between the two? Actually, both they participate in the thermoregulation, but while white tissue insulates heat and prevents the heat loss, then brown, it generates heat from inside with the help of the uncoupling protein. Uncoupling protein, it uncouples oxidation of the glucose and phosphorylation of ATP. You know that usually ATP is formed in the mitochondria, but 50% of energy dissipates as heat. But due to uncoupling protein, this percentage increases and more heat is produced than ATP. So this is exactly the function. And also we have to mention, besides that, except white and brown adipose tissue, there is a so-called beige tissue, and it is formed from white under the action of cold and stress. So what happens? Usually white and brown adipocytes, they are formed independently from different sources. Brown adipose tissue derives from the same precursor as smooth muscle cells, while white they from another precursor. But white cells, they could transform into beige and under the stress and cold, as I have said. And this event is accompanied by breaking down of one single lipid droplet into many, appearance of mitochondria, and as a result, white adipocytes, they burn their lipid and they transform into brown-like appearance. So this is exactly the desirable effect in people if they want to decrease the body weight. So we need to recommend patients with excessive body weight, with obesity, to undergo some procedures, to undergo physical exercises in the cold air, for example. Okay, yeah, and also I want to say that adipose tissue, it produces lots of biologically active substances, and it could be considered as a large and giant endocrine gland in our organism. Those substances collectively are called adipokine. Adipokine, this is a group of hormones. First was discovered in the 1994, and since that time lots of them were discovered, and they participate in the regulation of the body weight, of the glucose metabolism and inflammation. That's why increased amount of adipose tissue makes people prone to not only obesity, but to atherosclerosis, hypertension, diabetes mellitus, and even cancer, as it is written here. This article is recommended to read in case you are interested with this problem. So why obesity is so dangerous? Not because it overloads our skeleton or heart, but also because it makes people prone, it makes them susceptible to different chronic inflammatory processes, to atherosclerosis, diabetes mellitus, and even cancer. So body weight should be regulated strictly, especially with aging. And here we have our specimen with large giant adipocytes in it. Actually, adipose tissue should be stained with a so-called Sudan dye, and special procedures should be followed to prepare the specimen with adipocytes, because with the help of hematoxylin and eosin, fat couldn't be stained. So in conventional histological specimen, adipocytes could be seen as empty large cells, but in this specimen we can see large adipocytes with one huge lipid droplet. So it should be white adipose tissue and white single blood vessel inside. Okay, then another specialized type of connective tissue, this is the reticular tissue. It is also called hematopoietic tissue or lymphoid tissue in different textbooks. The difference is that reticular tissue, this definition, this term includes only reticular fibers and cells, that's what's shown here. And lymphoid tissue includes also lymphocytes put between those cells. So almost the same. And hematopoietic tissue means reticular tissue with hematopoietic cells inside it. So almost the same, but the difference is in the terminology. So what is the reticular tissue? This is the three-dimensional scaffold for organs where blood cells are located. For example, for lymphoid organs such as spleen, lymph node, thymus, not thymus, I'm sorry, in thymus reticular tissue is absent. And also for red bone marrow, hematopoietic organ. The problem is that in such organs, blood cells, they can't contact one with another. They do not form intercellular junctions. So to organize them inside the organ, to put them in a proper position, there should be a network, a sponge-like three-dimensional scaffold to organize them, and this is exactly what is reticular tissue. So it is represented by reticular cells and reticular fibers, and its function to organize hematopoietic or lymphoid cells inside respective organs. And here is the specimen of the reticular tissue. This is the high magnification of the lymph node. And here we can see pink reticular cells, here they are, and here you can see this reticular network, this pink reticular network inside the organ. Here it is, exactly, we can find it. Yeah, and lymphocytes put between those cells. So together it is called lymphoid tissue, and reticular tissue is here inside it, one of the components. And the last tissue today, this is the mucous tissue. Mucous, it is called so because it is devoid of fibers, and also it has only a few cells, and predominantly it is represented by the ground substance. That's why it is called mucus. Remember, it is present only in fetus in the umbilical cord. So it is considered as an embryonic connective tissue. In adults, it is absent. And in details, we consider this tissue in the topic placenta and umbilical cord. It derives also from the mesenchymal, the embryonic connective tissue. Okay, so we have we finished this topic, and let's summarize it. First, we discussed our fibers, ground substance, and cells, and after that, some special types of connective tissue like adipose, reticular, and mucus. And at the end, I want to check your attentiveness, and I want to give you an example from the USMLE database, but this time I want you to answer the question. And first, let's read the condition. Here you can read some data from clinical examination of the patient, but let's fix our attention on the questions. So there is the bone marrow biopsy specimen given in the task, and the question is, which of the following is the unique feature present in the most likely affected cells? So patient, it has some problems, and probably due to these cells. Something's abnormal with these cells. And you have to guess what cells are here. And the question is, which organelles are especially prominent and numerous in these cells. So first of all, you have to guess what cells are found in this specimen, and after that to guess what organelles should be very well developed. And if you were attentive along the lecture, you should recognize them easily. So your answers please put in the comments below, and then we'll discuss it. And next lecture I'll give you the correct answer. Okay, thank you for the attention, thank you for listening till the end, and good luck. And here, besides the enlarged specimen, is given for you to better investigate the structure of cells.